Right. My name is Justin Chow, and I'm going to be presenting RTDSP Project 4. So Project 4 is going to focus on IIR filter design. Project 3 focused on FIR filter design, so Project 4 is now going to deal with IIR filter design. So the first thing we're going to do is we're going to do section 4.4, which is DSK implementation in C. So this is more of like a tutorial example on how to implement IIR filters in Code Composer. So here we have the Code Composer Studios, and I've opened up some files regarding this project. So this file is relatively the same. This is the DSP configure header. It's the same as with the FIR filter. You can set the sampling frequency and all that stuff. So I've set it right now to 48,000 kilohertz because that's what the standard is without it being tampered with. So, and then we're going to talk about the interrupt service routine, ISR. Just like with the FIR filter, this is where the main part of our code will go into. So right now I've left it the same as the sample code in the book, and the sample code in the book has two numerator coefficients and two denominator coefficients for their IIR filter. And how they implement this is relatively straightforward. So first, just like with the FIR filter, you take your data, you read your data, and you load it into the first index, which is index 0 of the input buffer, which is X. Then we calculate the output using the dot product, using the input, which uses the feed forward coefficients, the B coefficients, and then also using the feedback coefficients. But notice this negative sign in front of the coefficient for the feedback. And so this is getting stored in Y0, which is the output buffer of the first index. Next, we have to shift. So since this is a relatively small buffer with only 2 slots, we don't even need a for loop. They just simply shift. They basically just dump the value over to the next spot over. And this is shifting the register using the shift register setup. So this gets it ready for the next input. So then we take the output that we calculate here and we output it through the left channel, and then we just write it out. So the main things to notice here is that our dot product now contains input values with feed forward coefficients and output values with feedback coefficients. This is the main thing right here. And right here it's implemented manually by hand, but if we're using higher order filters, we may want to develop loops, for loops that can help us quickly calculate the dot product as necessary. And we'll also need, for higher order filters, loops to help us shift these registers around. So that's all for pretty much how this is going to work. So this will work pretty similar to the FIR filters, just with those few minor changes. So we're going to go ahead and we're going to run this, debug this. So this filter, according to the book, is meant to be a DC reject filters that filters out it blocks all the DC, leaving you with only AC. So it's kind of hard to test this because all of our audio signals right here should all be AC. So if I run this, yeah, you'll hear it all the way through. So I'll try some classical music, see if that helps. So here's some classical music. Oh, it's quiet. It's very quiet here, so I might need to change some of those coefficients. All right, let me change one of those coefficients real quick. So since this is pretty quiet, we can change some of the coefficients to increase the gain. I think I made this too small, so let's put this at 0.9, and we can try writing this again. So if we run this again, oh, no, rather resume. There we go. So the coefficient, this feedback coefficient was too small, so I just quickly changed that, and so now you can hear it. So this is supposed to filter out. Since it's filtering out DC, I think it's supposed to make it clearer because it filters out some of that DC garble noise. But it's hard for me to tell at the moment because I don't have a really good example of how. But I'm pretty sure this sounds clearer. So let me turn this up. Well, regardless, that's what this is basically just a tutorial to demonstrate what the IIR filter does and how it's implemented in C. So with this knowledge, we'll be able to implement our own IIR filters, which I'll be covering in the next set of videos.